that at least one mean is different from the others, and that is true. Next question.
Okay.
Got it.
What requirements need to be checked when performing an ANOVA hypothesis test? And I believe B and C.
Yeah.
Equal. And that's a funny description of equal, if you ask me. Well, it's not 4 times bigger, so it must be equal.
I guess I should have read it. I didn't. Sorry. Next one.
Okay, you want me to read this one? Let's see. To check if each group is normally distributed, do the following. And that's a QQ plot, right?
I believe so.
Or, I mean, I thought it said something about a histogram, but everything we did was asking for a QQ plot, so.
It's a QQ plot.
Yeah. Okay.
We assume the variance in each group is the same if the following happens. And do you want me to read the answers or just the one that I think is right?
You can just read the one you think's right.
Okay, I think the largest sample standard deviation is less than 2 times the smallest sample standard deviation. So the second one.
The largest variance is less than 4 times the lowest one. Yeah.
I thought you said 3 times.
Yeah, that sounds.
I agree.
Oh, why is that different for me? Wait, no, am I looking at the one? Hold on.
Well, it's just worded a little bit different. Mine says the largest variance is less than 4 times the smallest variance.
Yeah.
Which means the same thing.
It does mean this, yeah.
I don't know why you'd have different wording. That's kind of scary.
Okay. An ANOVA hypothesis test is equivalent to conducting independent 2-sample tests between every pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? There are 3 samples, there are 3 pairs. 4 samples, there are 4 pairs. Oh, brother.
So would it be 4?
I think so, right?
I didn't
1, 1, 3, 1, 4. And then you do 2, 3, oh no, 2, 3, 2, 4, right? And then you do 3, we already did 3, 1.
I totally don't get this. I thought independent was not or independent was not paired.
Well, so I'm taking number 1, like they did. So we have 1, 2, 1, 3, and 1, 4, right? For the okay. Then you take 2. We already did. So then you would take. We already have a 2, 1. So then you do a sample 2 with 3, 2 with 4, right?
Yes.
Okay, and then we do. We already have 3, 1. We already have 3, 2. So then we have 3, 4. Right?
Yes.
Okay. And then we have 4, 1, 4, 2, 4, 3. Okay, so then we have 1, 2, 3, 4, 5, 6 samples.
So we have 6?
That's what I got.
I think that's right. So do you guys want me to look? I think we did this, well, it sounds about right to me.
Yeah, but they didn't actually have us work one of these out. Like they talked about it. You know what I mean?
Yeah, we didn't do any questions about this.
Yeah, I remember them talking about it.
Oh. I'll look for it in our.
So why, if there's 3 pairs, why is there not a 1 and a, let's see, 1 and 2? Oh, because they overlap each other. That's right. Okay.
She's eliminating the ones that are overlapping.
Okay.
Yeah.
So we're thinking this is 6.
Yes.
They talk about it on the second page of, but they don't, with our text, but they don't really, they talk about the 3 samples, 1, but they don't go really into details.
Yeah, because after that, nothing was really paired at all.
Yeah. Only because we do it in SPSS, so we don't have to do it.
Well, we maybe better find, because number 8 is kind of the same. No, it's never mind. I was thinking I was asking about the groups, but
Yeah, I think it's 6. That makes sense to me.
because there would be 2, there would be 2 duplicates, right?
Mm-hmm.
Yeah, there would be actually more than a few duplicates, but if we were to take out the duplicates, it would be 6, which would make sense.
Okay.
Okay, the soccer shoes data, are we ready to move on?
Yeah, I'm ready.
So number 9, the soccer shoes data has 6 groups, A, B, C, and D stocks. These data can be found in the wiki. Load all 6 samples into a quantitative interference procedures spreadsheet. Or perform an ANOVA test in SPSS. Why can't they just say that? And observe that the p-value is 0.0809. Remove the stocks data. What is the p-value?
What?
Wow.
Okay.
What does that even mean? Okay,
I
so
don't know.
Yeah.
This is a data set. This is not just randomly floating stuff. Yeah, soccer shoes is here.
so pull out the soccer shoes.
Never had to take data away.
No. Oh my goodness.
So we do analyze, compare means, and do we do one-way ANOVA?
Yeah.
Yeah, we can do that and see if it matches the p-value, and then we can try to go from there, I guess.
Yeah.
How do they have us do things we haven't done before?
I think it's so. I don't think it's different from what we've been doing. I think it's just they word it differently.
But I've never had to like take anything away, right?
Mhm.
So do we have to change? We have to make a new column to start with.
Yeah, I think did you have to recode it? I don't remember what I did.
Yeah.
Is that what you're doing, Christy?
Yeah.
Because we pretty much had to do that for everything, so I'm guessing. And are you doing the footwear?
I thought it was soccer socks.
The data can be found. Let's see. Soccer shoes data has 6 groups: A, B, C, D, E, socks. Remove the socks data.
Well, I mean to recode it.
It doesn't really. describing. Yeah, I'd probably do footwear, right?
Yeah, to recode it. Sheesh. Okay, now I'm doing compare means.
Okay. So what are you doing after you code it? Are you analyzing it?
Yeah, analyze and compare means. And then,
Okay. So we're doing
and then the one-way ANOVA test. I'm just seeing if I can get to that.
Yeah.
If I can match the. Oops. Okay, so the p-value is 0.0809.
Okay, what's the p-value?
Well, before you remove socks, I was just trying to. Okay, I don't think I have enough information here. What am I doing? I haven't done this since yesterday. I forgot all about it. I forgot how to do it.
Okay, so I got this point. I got that point. The p-value with the socks. So how do we? So now
Can you repeat your question? I can't hear you.
Oh, how do we remove the sock data?
That's what I'm trying to figure out.
We go to data. Sort variables. I wonder if we copied and pasted.
Is there maybe something in the video tutorials?
I don't know. Can you just point on it and cut? Wait.
Hello, this is Brother Kumar from
Oh,
the Math
snap.
Department, and this is the supplement of Lesson 14 Dealing with ANOVA. And I'll be covering what SPSS codes that you need to do, or SPSS commands that'll help you through Lesson 14.
Maybe we just delete everything.
Histograms. Then I'll follow up with doing this is
Like go to
I'm
the
just going to try
original
deleting
page.
it.
So first of all, let's look at histograms. So what I'm going to do is I'm going to go to condition, COND, recoding.
Just deleting all the socks.
Yeah, I'm just going to try it and see what happens.
I'm gonna try that.
Which is in this case a miss, will be assigned to 1. And then grateful, since it's second alphabetical, it's assigned to 2. And then passive is assigned to 1.
Hold on just a sec. I'm gonna go check on something. I'll be right back.
Okay.
Okay, I just deleted it. Are you gonna do retransform and everything?
Well, I wonder if it's just going to change it or if we have to redo everything. Because my socks data is still there. I think we have to redo it.
Okay. We still have the variable in there from when we redid it from the transform. Everything's still the same, looks like.
Yeah, I think so.
Let's see what it did. Okay, now I got sigma 0.309, and the stock
That's-
is removed.
That's what I got too.
Woo woo! Yes.
A consensus of 2 means it's the right answer.
Keep that. Oh. Okay, we gotta hurry. I only have 10 minutes. What? This value goes up when only one group is removed. Compared to 2006 well, that was true. I don't know if it always
It went. Oh, it did go up.
Does it always go up?
That's the automatic recode. So the next thing I want to do is that I want to cover how to do Explore in SPSS. So now what I'm going to do is pull statistics.
Oh, we figured it out.
Oh, okay. How did it go?
We just deleted the SOX data.
Oh.
Yeah. And we got 0.309.
And then the next question says that the p-value always goes up when one group is removed. So it did go up, so I guess we're on the right track.
So do we say true?
Compare the few all 6. I guess it did.
It would be false, wouldn't it?
Well, it went up.
Oh.
Because it was 0.081, and then we took away the stocks, and it went up to 309. 0.309.
Did you remove all the groups though, or did you just remove one?
Just one, just the SOX.
And it went up?
Yeah.
Uh-huh.
Yeah, I don't know what to do.
I don't remember talking about that either.
Yeah, I don't remember that.
I'm just going to say yes. Because it's true.
Okay.
Okay, what is the highest p-value you see when removing only one group? You'll need to compute in ANOVA for each possible option. What?
Okay, I deleted the SOX data, so how am I supposed to get that back?
Oh,
Do Control Z.
I think it's been too long.
go
Control
back
Z.
and do it again? Or we just...
So it says you need to compute ANOVA for each. Is that what it says? Yeah. You will need to compute an ANOVA for each possible option.
What? Now we have to keep removing things, or what?
I think so.
Oh my god.
But only one group at a time.
Yeah, one group at a time.
Not including the one we just did?
I wonder if there's a way we can do this with the data that's already been figured, like manipulate it somehow. There's got to be an easier way to do this because the only way I can see is to reload it every time and take one group away.
Yeah, that's going to take more than 10 minutes.
I guess we could work as a team.
I ran the numbers before I came, because my SPSS isn't working, so I ran the numbers before, but I don't remember how I got that one.
Okay, I'm gonna look at the Explorer thing with the QQ plot. And then,
I feel like there's an easier way to do this.
I do too. There's got to be an easier way to do this. Got to be a way to I'm just gonna have to delete this because the socks tab is gone.
right? Okay.
So
We can get
load
all
it
the
again.
variances, right? Like,
What's that?
we can get all the variances by doing the QQ plot, and then it gives us a summary.
And then you're saying we just subtract them individually or something?
Yeah, I don't. Yeah. So for the first thing, A, 27.58. B, 29.484. B, like, I don't. 27.208. B.
How do you do that?
We already took that one away. Right?
Why is it? Did they go over? I just don't remember this going over through our review. Or like
We didn't.
our lesson.
Variances
We
here.
didn't.
Here's the variance for the events, and variance for the grade and variance for the hassle. So you can compare those to see the largest. In this case, it's the grade
Okay.
multiplied by the smallest.
So when we took the sock one away, the highest. Oh, I'm trying to find the P.
You can also get means, standard deviations. You can also get sample size as well too. Also,
Oh.
plots. Plots with tests. Here's the output. These are the numerical statistics. You can look at what the variances here. Here's the variance for the events group, the variance for the grade group, the variance for the hassle. So you can compare those to see the largest. In this case, it's the grade multiplied by the smallest, which is the hassle.
Okay, so what about if you do run the ANOVA test and wait, you do. Let's see, what is it? Ay, why isn't this easier?
I don't know, but I have to leave in 6 minutes.
So if we do, the normal way to get it, well, I don't know if it'll give us, it needs to give us we're looking for the p-value, right, for every single one of them?
Because, yeah, when only removing one
Well,
group.
it's missing if you take away. It wanted. Let me look at it again. It seems like we were supposed to compare the highest p-value when removing only one group.
And or do we get that information as we do, like if we pull out or run an ANOVA test?
Yeah.
And we make sure that it says like what is it?
So
So we did the sock. So altogether, it's 0.0809. If we remove the socks, it's 0.309.
right?
So I guess we're supposed to find out if we remove any of the other ones, what the highest p-value would be.
Right, but when you ran the test, did you test, what is that thing called?
So here's the output that.
Sorry, I'm just looking at the video, and so it's.
So here's the output. And then I can do some other things as well too. If I go to plots.
When you put plots and then you test for normality within the test, and then did you guys do that as well?
I did. Well, I reloaded it now, and so I have all the information is in right now, and I reloaded it. So
does it not give you the actual stuff on there?
Okay, let's see. So
I'm gonna look at the last time I took that class. I'm gonna look up the quiz and see if it's the same. So at least we have an idea what we're looking for.
I'm going to remove 8. See what happens. Okay?
So what we're looking for,
okay.
The answer that we're looking for is 0.448. Do we have any of those numbers anywhere?
0.448 is the highest?
Yeah.
So somebody want to do B?
Yeah, just hang on just a second.
We need footwear, right, for the group code?
Sorry, I'm trying to look. We have that.
Okay, when I removed A, I got 0.060.
Was that E or D?
I removed A.
Oh, A.
Are you doing B?
You feel like you're like hanging out there all alone, Christine? Sorry, I was just trying to see if there was a way because this gives the p-value. It's the SIG period, whatever that's supposed to mean, on the test of normality chart. it gives that value for each one. I was wondering if we just subtracted that somehow from the, but they had two different tests and there's two different sets of numbers. So I don't know. I guess we're just going to have to slog through this one at a time. So, sorry, I will do B.
Okay, I'll do C, and then I have to leave.
Okay.
Unfortunately.
I'm sorry.
I'm debating whether I just stay and I get picked up.
Well, the other questions,
It'll be fine.
this one looks like the worst one, I hope. Are you deleting the group code as well when you do this, Christy, or just the set of numbers?
Just a set of numbers.
Okay. Because then I might be able to get it back if I just do that. Okay, B comes up as 0.052.
Okay.
And you're doing C?
Yep.
Yay, got it back. I'll have to reload it. Okay, so I'm doing D.
Okay. Okay, C is 0.448.
Hey, that's supposed to be the answer.
Okay, we might be getting somewhere.
And I have to do, okay. No, big constant, no, right?
Okay, D, as in dog, is 0.031.
Okay. Sorry, I haven't done E yet. Ooh, you're doing it fast. I don't know what you're doing, but I mean, figure that out. You're doing it faster than I am.
Well, I'm just deleting the section, and then I am just doing the ANOVA test. And then after I get that number, then I do Control Z and I get the data set back.
Oh.
So I can do E real quick if you want me to. See if it does indeed match up. Okay, E is 0.050.
Okay.
So C would be the highest. That's what we're looking for, right? Is the highest?
Yeah.
Yes.
0.448.
Yes.
Okay. I'm gonna pick up my children. Like, okay, let's just keep going.
Okay. Good luck. It looks like the rest are not too bad, maybe.
Yeah.
So the samples, the next one is the minimum of all the samples. So the smallest variance. Oh wait, I don't know if I'm looking at the wrong one.
But that's that other chart, isn't it?
Yeah. So we have to go back in.
So hopefully, let's see if I can get a full thing back.
Oh, this is giving you great practice.
Okay, so let's see. So we just need to compare the variances on that big chart, right? Is that what we're doing?
Yeah.
Okay. A is 27.358.
Wait, for 10? So okay, go ahead. I'm
Okay,
listening.
when all 6 samples are used, what is the minimum smallest variance? Okay, I'm just going through and looking at all of them to see which one is the smallest.
Sorry,
So
I had to space that moment.
it's 27, B is 29.484. C is 27.208. D is 53.158. And E is 31.011. So the smallest is C, which is 27.208.
Can you repeat that
The
again?
largest was D.
The smallest out of all, the smallest variance is 27.208, and that was for C.
Right.
And then was the largest D.
Would it the 53.158?
That was D. D as in dog is 53.158.
Okay, got it.
So is that 4 times larger? No. Okay, so that's true.
Start to QQ plot. What
Let me look real quick.
is right?
These normally abnormal QQ plots look really, let's see.
Okay.
They always look abnormal to me, but
I think they're normal in comparison, though. Right?
they look pretty right along the line there. Yeah, they look pretty normal.
Okay, so I'd say normal. Right?
Yeah, I think they look normal. Left.
Always to the right.
That's to the right,
Yeah,
isn't it?
Right.
I think so.
It's right skewed and it's everything to the right.
Yeah. Okay.
Are we done? Is that it?
Yep.
Sheesh.
Yeah.
That was ugly.
It was. Wait, don't submit it yet. Number 9 was wrong. It is false.
Oh.
Oh, really?
Yeah. And then